Hello, calculus fans. All right, we're going to try to compute the derivative of x raised to the sine x power. And as we're going to see, this is sort of a special circumstance, a very unusual sort of derivative. Now, in the previous problem, we discussed logarithmic differentiation in a context where we could have actually done it in sort of an ordinary way, just using things like the product rule, quotient rule, chain rule, power rule. All those sorts of rules could have taken care of that previous one. It would have been quite a mess, but it is definitely doable. However, in a situation like this, where you have an exponential and you have a variable in both the base and the exponent, this is a circumstance where there is no choice but to use logarithmic differentiation. If you go back and look at that previous problem, that was not true before. There were variables in the base, but there were no variables in the exponents. So just to repeat, if you have a variable in both the base and the exponent, you have to do it using logarithmic differentiation. Now, it isn't actually any more difficult than the other types of logarithmic differentiation. So we're going to let y be equal to x raised to the sine x power. And then we're going to take the logarithm of both sides. You should be thinking about taking the logarithm of both sides or using logarithmic differentiation because there's an exponent, and logarithms handle exponents very nicely. By taking the log of both sides, we get log of y equals log of x to the sine x. And remember, we have a property of exponents and logarithms where if there's an exponent on the inside of a logarithm, you can bring that in front. So if we do that here, we're taking this sine x and moving it in front. Okay, so now that sine x is out in front, there are no more exponents. Now this is something that we can differentiate relatively easily. So let's go ahead and do that. So we're going to differentiate implicitly, and as usual, we're going to try to solve for y prime. So when we differentiate, as usual, on the left-hand side, we'll get 1 over y times y prime. Then on the right-hand side, we use the product rule to differentiate sine x log x. So we have first times the derivative of the second plus the second times the derivative of the first. Remember, our goal is to solve for y prime, so now we multiply both sides by y. And we don't quit here. We take this y and replace it with the original y that we started with. Then we quit. So here you can see that this y just got replaced with x sine x. That was the original y that we started with. And then this is it. We're not going to do anything else. So just to reiterate, we had to use logarithmic differentiation because we had an exponential with a variable in the base and the exponent. That's all for now.